Okay, we are going to look at problem number 7 from the free response review packet. So we're starting out with this one. So this is a differential problem, right? So they've given us this differential equation, and they're asking us to do different things with it. So this is actually a pretty common problem too. So the first thing they're asking us to do is to sketch a slope field. Now we have not dealt with slope fields, but they're actually very easy to do. So let's kind of talk about that, and then we'll do this one specifically. So let's take this equation. So they give us this equation: dy dx equals x squared y minus 1. Basically, think about what's going on here. When we plug in numbers for x and y, out comes a slope, right? So for example, if I were to plug in, let's say I were to plug in for, let's see here. What if I were to plug in the point, actually, let's just do this over here. So on this graph, let's plug in I want to just kind of plug in I'm going to plug in the point 1, 3, right? Yeah, I'll plug in the point 1, 3. This is just kind of a random point. So we're going to plug that in, right? So what this means is I plug in 1 for x, so this is 1 squared, and then I plug in 3 for y, 3 minus 1, and I get 1 times 2, which is 2. Okay? What that means, right, is it means that the slope of the tangent line at this point 1, 3, is 2. So what I do is I draw a little line with a slope of 2. That's it, right? By the way, your slope doesn't have to be perfectly accurate. In general, what they're looking for is they want to see, if I've got slopes that are positive, negative, and 0, they want to see that. I want to see that a slope is positive. I want to see the slope is negative. I want to see that it's 0. If you have a slope that's supposed to be 4 and you make the slope, 2, nobody cares. Okay, as long as it was positive. So let's do another point, and then I'll have you guys. Then we'll kind of go do the rest. So let's say let's do another random point. Let's choose the point. How about -1, 2? Okay, so let's choose the point -1, 2. So in this case, right, what do we get? So I get -1 squared, 2 minus 1. That's going to be 1 times 1. So we have a slope of 1. So I put a little slope of 1. Notice this one was 2, this one was 1. Sure, it's a little steeper, but that's fine. So again, that's all you're doing. So in this case, what they're asking us to do they're asking us to do it for each of these points. So you're going to plug in each of these points and go for it. Now you might say, well, that's while it's easy, it might take a little while. Not really, because there's some shortcuts that we can do. So for example, I notice, right, when x equals 0, all the slopes are going to be 0, right? Because this is a product. So I can go boom, 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 boom. All those slopes are 0. Also, I notice when y equals 1, right, all the slopes are 0. So boom, boom. So again, notice you can pretty quickly put in some values, right? At this point now, we've already done, all we have left is 1, 2, 3, 4. Okay, so let's go and finish that up. Let's do, I'm going to do, and again, these can be done in your head. I'm going to do this point right here, which is the point 1, 2. So 1 squared is 1, so it's actually the only thing that matters is this. 2 minus 1 is 1. Okay, let's do this point right here. So this is the point -1, so this is -1 squared, plug in 2, so that's going to also be 2. Then we have 2 more. So let's see now. X is, let's do this point. Sorry, you can't see that. I'm going to do this point. So x is 1. In this case, y is 0. So this is -1. And actually, this is going to be the same thing on the other side. Okay? Boom. Done. So what they're going to be looking for as they go through and grade this, and again, I can't tell you exactly, but they're probably going to be looking for, 1, are these things right here, do these all have a slope of 0, right? On the y-axis on the line y equals 1. Okay, are these all slopes of 0? And then generally, maybe they'll say, hey, these values, are they positive? These values, are they negative? That's as detailed as they're going to get into that problem. Okay? Anyway, that is a slope field. Let's keep on going. So while the slope field in part A is drawn on only 12 points, it is defined for every point in the xy plane. Describe all the points on the xy plane for which the slopes are positive. So what they're basically asking us, right, is where are these slopes? Where are all our slopes positive? So it's kind of in this case it's easier to say where it's, well, let's kind of look at this. I think you guys would agree. Let's kind of talk about it. So they're positive, of course, when x is not equal to 0, right? Because when x equals 0, the slope is 0. So that's one place where that's one case where they're not positive. Also, I think you'd agree they are positive when for all points above the line y equals 1, right? When y is less than 1, so this is always positive, so I don't have to worry about it. This is the only thing I need to worry about. I think you guys would agree when y is less than 1, this thing's negative, right? So 0, -1, -2. So the only thing so when y is less than 1, everything's negative. So let's put that all together. So what I'm going to say, dy dx, or you could say, the slopes are positive, or, the slopes of the tangent lines are positive. But I'm going to say dy dx is greater than 0 when, first thing, x is not equal to 0. And what else did we say? Y is greater than 1. Okay? I don't need this thing right here. I had it. I don't know why I had that there. Okay, let's continue. That's all there is to it. That's all there is to B. So let's move on to C. Now, C, I'll be honest with you, this I could have given you on our separation of variables test. This should be very straightforward. There is nothing to see here. This is a separation of variables question, right? They're saying find the particular solution, y equals f of x, for this differential equation given this initial condition. So this is simply separation of variables. Okay. Do notice though, they say y equals f of x, so they want this solved for y. So let's go and do it. Reminder on separation of variables. I'm going to separate my y's from my x's, and then I'm going to integrate both sides. So for the left-hand side, again, you can usually use substitution. You can kind of look at it and know it's going to be a natural log. So y equal natural log of y. The left-hand side becomes a natural log of the absolute value of y minus 1, and that's going to be equal to 1/3 x cubed plus c. Now, I cannot emphasize enough, this plus c, we've talked about it before in separation of variables, is super important, okay? If you leave out that plus c, you're probably giving up almost all the points on this problem. You'd probably be giving up at least 2/3 of it, okay? So make sure for separation of variables you have that plus c. It's going to be very important. So from here, let's keep on going. So I want to get rid of that natural log. So I'm going to do this. So we get on the left-hand side the absolute value of y minus 1 equals 1/3 x cubed. Sorry, doesn't equal that. Equals e to the 1/3 x cubed times e to the c1, right? Just emphasizing this was all an exponent. So continuing here, notice what I'm going to do is I'm going to let e to the c1 equals c. So I get y minus 1 equals c e to the 1/3 x cubed. So y equals c e to the 1/3 x cubed plus 1. Now we have to solve for c. So what do? We plug in the point 0, 3. So I get 3 equals c e to the 1/3 0 cubed plus 1. So I get 3 equals c, right? Because this whole thing right here, e to the 0 is 1. So it's going to be 3 equals c plus 1. So 2 equals c. So my final answer, and again, it is important to have that final answer, is y equals 2 e to the 1/3 x cubed plus 1. Let me double check to make sure that is correct. That is correct. So couple of notes. One, again, notice they asked us to solve this for y, so it's got to be in this form when we are finished. Two, again, I cannot emphasize enough, make sure, right, that when you do your separation of variables, when you integrate, you get that plus c, because we have a family of functions, right? When we do this, when we integrate this, we get a family of functions. Then they're saying, hey, you have all these infinite number of functions, but we are looking for the function that specifically passes through 0, 3. Go and find it. And we can't do that unless we put in that plus c from the original. Okay? That's problem number 7. I'll see you in problem number 8.